Welcome to the project Programming a God. Today we will be solving the New Year chaos problem from HackerRank. Let's look at its problem statement first. This is the problem statement. Please pause the video if you want to read it, or you can just listen to the explanation. The problem states that at a festival, there is a roller coaster ride, and for the tickets to that ride we have a line of customers indexed initially from 1 to n. Also, each person in the line can bribe at most 2 persons in front of them to move forward in the line. Now, we will be given an array of integers that denotes the final state after all the bribes have occurred. Our job is to find out the minimum number of bribes it will take in the line to get in its current state, and if any person makes more than 2 bribes, then print 2 chaotic. So, that's the problem statement. Now let's look at its input format and other stuff. The input format is simple. There are T test cases, and each test case will have a number and an n space separated integers. The constraints state that the test cases will be less than 10 and the size of the array will be less than 10 to the power 5. Output is pretty simple. Print the minimum number of bribes, and if any person makes more than 2 bribes, then print 2 chaotic. We also have 2 sample cases. Let's understand one of this graphically. Here we have an array that shows what the final queue looks like. Let's understand this. Initially the queue looked like this. First person at number 5 bribed number 4, making it the first bribe. Then he bribed number 3, making it his second bribe. Also, the person at number 2 bribed number 1, making it his first bribe. So the total bribes become 3, and that's our answer. Also, if the person at number 5 would have made more than 2 bribes, then we would have printed 2 chaotic as answer. Please pause the video and see if you can come up with any solution. The solution depends on whether you are able to make the following observation. The number of bribes that a person at position I makes is the count of number of integers that are less than it from I to n. Let's start from the end. For person 4 there are no numbers that are less than 4 behind it, so the bribes made by number 4 is 0. Similarly for number 3 the bribes made are 0. But for person 5 we have 2 numbers that are less than 5. So the bribes made by person 5 is 2. For person 1 there are 0 bribes. For person 2 we have 1 number less than 2 behind it. So, the bribes made by person 2 is 1. This gives us total bribes as 3, and that's our answer. It's an observation that you should have made. But is this the best possible solution for this problem? Let's see. We can loop through the array, and for every element I we can count the number of integers that are smaller than it between I to n. But it has a complexity of O of n square. Remember that a person can only make maximum of 2 bribes. Let's use this and optimize the solution. If a person I is not present at his original position, then he only has 2 choices. He is either present at position I-1, or else he is present at position I-2. If he is at any other position, then the answer is 2 chaotic. In the array above, person 5 has only 2 choices. He can either make 1 bribe and move to person 4. Or else he can make 2 bribes and move to person 3. We can check this condition for all elements from n to 1 within a complexity of O of n. So let's do this. Run a loop from last element to the first element. For each element, check if the element is present at his original position or not. If not, then check position I-1. If present, then increment the answer by 1 and swap the values. If not present at I-1, then check position I-2. If present, then increment the answer by 2 and swap the values as shown. If the person is not present at any of this position, then the answer is too chaotic and break the loop. Next, we have provided you with the C++ code for this problem. Please subscribe if you want to see more such videos.